Today we're going to take a look at projectiles, right? And a projectile is just an object that is given an initial velocity, and then nothing else acts on it. So this is actually it's a special case of free fall, okay? And so I'm going to say free fall with non-zero initial velocity, okay? And so all that means is we only have to consider one force acting on the object, okay? And we've already looked at this a little bit, right? We took and we rolled a marble off the edge of a desk, and we know when that happens, it falls down like that, okay? And it hits the floor. And this path, the path a projectile takes, that's called a trajectory. And what we're interested in is finding different points on that trajectory, the range of the trajectory, how far it goes, right? So range is actually the change in x. The height is exactly what it sounds like. Generally, this is measured from the ground. Okay, what's the highest point on that thing? So the maximum height, so the maximum vertical position, I'm going to say maximum y, okay? And we can get all this information, but really, since it's a free fall problem, it's a pretty straightforward thing. We only have to consider gravity, okay? And so if we take that example problem of the ball on the table, this is one you guys have already done, since gravity is the only thing that affects the motion of this ball, okay, what we need to know, we don't care about this. This is velocity in x. It doesn't change anything, right? Gravity doesn't say, oh, I'm not going to pull on you because you're moving, okay? Gravity continues to act regardless. So all we really need to know is its velocity in y, and since it's horizontal, this is 0. We need to know its height. Okay, we need to know the distance it falls, which is height. So that's really its initial position. Where does it start? And we also need to know the acceleration, which is going to be due to gravity, so A equals g. And from that, we can use the second kinematic equation, which says y equals 1/2 at squared plus v naught t plus y naught, right? And then you put in everything you know. But since this is only in y, right? That's the biggest thing to do, is keep x and y separate. Okay, then we only want to look at the y motions. So we have y, which is our final position. Well, it lands on the ground, so that's 0. 1/2 at squared. Well, that's 1/2 negative 9.8, right? Gravity pulls down. T squared plus v naught t. Yeah, it is moving in x, but it's not moving in y. So that's v naught y. We don't have to consider it. Plus y naught, well, that's whatever its height is, right? And so from this, we can solve for t, and we can figure out t, which is the time it's in the air. Okay? And then, if I want to know the range, then I go back to the x direction, and I can say this exact same equation, okay, right? X equals 1/2 at squared plus v naught t plus x naught. Okay, but now we're going to use the initial velocity in the x direction. The acceleration in x will be 0. Gravity pulls down, it doesn't pull forward. Okay, and so then I can say, all right, well, I don't really care where it starts or where it ends. What I really care is the difference between them. So I'm going to subtract that over, and I'm going to get the range, the change in position, is equal to v naught t. And that's generally true for projectiles, because there's no force acting in the x direction. The only force acting is in the y direction, so delta x is v naught t. Okay, so there's a problem today to work that's just strictly horizontal. We've done things like that before. I'm not going to do an example problem like that. Hey, my wife made it to work. But I do want to do one where we look at something that's maybe launched at an angle. Say like a golf ball. If a golf ball is resting on a tee and it gets hit this way at 25 meters per second, okay, and this angle's 30 degrees. How do I deal with that? How can I figure out its range? I want to know its change in position, and I want to know its maximum height. Okay, well, it's just like before. Okay, I have to consider x and y separately. So I've got to find my x values, and I have to find my y values, and I have to keep them independent. Okay, so initial velocity in x. Okay, so then I've got this triangle, right? This is v naught x. We've got this leg of the triangle. This is v naught y. And I'm just going to break this up into vectors. So v naught x is 25 cosine, because this is the adjacent side, cosine 30. V naught y is 25 sine 30. It's the opposite side. Okay. Acceleration in x, 0. Nothing's changing that. Acceleration in y, negative 9.8. It's gravity. Initial position, it started at 0, and it even started at 0 height. So our initial position here is also 0. Okay, and so now I can use this information to actually find first the time, right? From this I'm going to get time, and then I'm going to take that and use that time over an x. So really the biggest change that we had to deal with is just to split this up into vectors first. Okay. If the initial position isn't 0, then of course you have to put that into your math. But then you're just solving the second kinematic equation. Okay. Good luck with those problems. They're posted on Moodle. Let me know if you have any questions.